So, in today's class, good morning, everyone. In today's class, we're actually going to talk about motion. And when you hear the word motion, what comes to your mind? You know that it has to involve what? Movement of things or body. So from a place to another. So that's is just the change of position. So motion is the change is the change of position of a body or an object or an object with respect to time. Now, why do we say with respect to time? It's because a body can actually change from a position or an object can actually change from a position, but you have to let it be time bound in the sense that uh, body A wants to change from position A to position B. Now, the fact that this body A changes from this position A to position B shows that what it's actually what a motion within a certain time bound. So let's talk about the types. Let's talk about the types of motion. Let's talk about the types of motion. Now, the first type of motion is linear or translational motion. Linear or translational motion. Now, linear or translational motion is actually the change of position of a body or an object along a straight path. So is the change of position of a body or an object along a straight path. Along a straight path. A typical example is what? A moving car. A moving car. So a car moving is actually performing what? A motion. So number two is circular or rotational motion. Circular or rotational motion. Circular or rotational motion. So when we talk about circular or rotational motion, they are change of position of a body or an object along a circular path of which their velocity will be directed towards what? The fixed center. So is a change of position, change of position of a body or an object along a circular path, directed towards a fixed center. And a typical example of that is rotation of fan blades. I know we all have fan in our house, rotation of fan blade. Another example is the earth which we are in. That's rotation of the earth about its axis. Rotation of the earth about its axis. Rotation of the earth about its axis. So, rotation of the wheel of a car, yes, is actually what? Rotational motion also. So the third thing we're going to talk about is random motion. The third one, we're going to talk about the random motion. So random motion is actually the what? The movement of a particle of or an object in an irregular manner. So it doesn't have a regular direction. So it's a movement of a body or an object in an irregular manner. An irregular manner. So random motion, we said, is the movement of a body or an object in an irregular manner. The typical example of this is what? Brownian motion. Brownian motion is just the movement of gas particle in an aphasad manner. So from there, we go to oscillatory motion. We go to oscillatory motion. So we go to oscillatory motion, and we can actually say, I can remember while growing up, there are some instruments in our school then. There are some playing instruments in our school that we do use to play. So we'll talk about them in this aspect of motion, oscillatory motion. Now, oscillatory motion is the to and fro motion of a body about a fixed point. Is the to and fro motion of a body about a fixed point. Oscillatory motion is the to and fro motion of a body about a fixed point. So example is what? Swing. Motion of a swing. Motion of a swing. Because so now we've talked about oscillatory motion, we've talked about combination of motion, talking about bringing translational and rotational motion together. And a typical example of that is a moving car. And when we talk about a moving car, that is the wheel of the car is actually undergoing translational motion. The movement of the tires, rotation of the wheel is what? Undergoing rotational motion actually. And the movement of the car is now undergoing what? Translational motion. So swiftly, I talked about oscillatory motion. We said I was trying to explain this a simple pendulum. Now, let's say this is a fixed point and this is the bulb. This is the bulb attached to this rope. Let's say this is a rope and this is the bulb attached to the rope. Now, point A and point B shows the maximum displacement of this bulb on both right hand side and left hand side. So point M is the fixed point. Now we said oscillatory motion is the to and fro motion of the body about a fixed point. Now this is a fixed point. Now if you tilt this thing towards the left and you leave and you release it, it will go to B, come back to A, go to B, come back to A. And as time goes on, the velocity reduces. The velocity reduces, which means it won't reach point A, it won't reach point B again. It keeps reducing. Maybe it will reach this point till it comes back to rest. So that's how the motion of oscillatory motion works. So now, talking about equation of linear motion. What can be done when we talk about equation of linear motion? We have some equations, and it gladdens my heart to tell you that the first equation of linear motion is gotten from average velocity. Average velocity. Average velocity equals to what? Total distance. Total distance over what? Over total time. Over total time taken. So average velocity. So now I said the first one is being gotten from average velocity equals to total distance over total time taken. Now for we to have average velocity, meaning we need to have an initial velocity and we need to have a final. So when it comes to the average, then it has to be divided by what? By 2. Now initial velocity plus final velocity equals to distance over time. Now, in motion, distance is denoted with what? With x. Initial is u plus v. This one is over 2. Here is over 2 because we said average. Now, equals to distance over time. Now, in this point, in this place now, we are going to what? Cross multiply and make the distance the subject of the formula. So that's 2x equals to u plus v multiplied by what? By t. U plus v multiplied by t, and divide both sides by 2. So x finally equals to u plus v over 2 all multiplied by t. So that is what? Equation 1. Now, quickly, let's talk about equation 2. Equation 2 is being gotten from what? From acceleration. And acceleration equals to what? Equals to change in velocity. From the definition of acceleration, it says acceleration is the rate of change of velocity with respect to time. So acceleration is change in velocity over time. So acceleration denoted with a change in velocity. For you to have a change in velocity, it has to be what? Final minus initial. Let's say you're going somewhere, you have a starting point and you have an end point. So that's final minus initial over time. Final minus initial over time permits me to change this. Final minus initial over time. So then let's cross multiply. Then we'll make v, which is the final velocity, the subject of the formula. So v minus u equals to what? A multiplied by t. So v minus u equals to a multiplied by t. Make v the subject. If we make v the subject, if u crosses equality sign is negative here. If it crosses equality sign, it means that then we will have what? A positive u plus what? At. Then this is the second equation of what? Of linear motion. Now, the remaining two equations are being gotten from these two equations. Now, is either you eliminate v to get the third equation, or we eliminate t to get the fourth equation, or we eliminate v to get the third equation, eliminate v. So, okay, so we said the second equation is being gotten from acceleration. We've actually proved that, and v equals to u plus at is the second equation. Now, I said to either get the third equation or the fourth equation, you either eliminate velocity or you eliminate time. Now, having said that, equation 1 is what? X equals to u plus v over 2 all into t. So that's equation 1. Now, equation 2 is what? V equals to u plus at. Equation 2. Now, we need to now what? We can as well put the value of v in equation 2. Put v equals to u plus at in equation 1. So Whenever you see v in equation 1, you put u plus at. So s equals to u plus, instead of v now, I'll put u plus at all divided by 2. So now u plus u, that's 2u plus at over 2 all multiplied by t. Now we can as well open the bracket. S equals to 2ut, that's 2u times t, 2ut plus at times t, that's at squared, all divided by 2. All divided by 2. Now, there is one thing we can as well do. Let's rub this. There's one thing we can do. Now, let's assume you have a plus b over 2. You agree with me that we can say it is what? A over 2 plus b over 2. We can split it in this form. And that is what we are going to do to the next thing here. So we have x equals to 2ut. We can put over 2 and what? At squared over what? Over 2. These two cancel this. S equals to ut plus, now I can say half at squared. So that's the what? Equation 3. I hope we'll understand how we got equation 3. Now we are going to move to getting equation 4. Now, the fourth equation, I made mention that, you know, the first equation is still s equals to u plus v over 2 multiplied by t. That's equation 1. So equation 2, that's v equals to u plus at. Now, we eliminated v here and we got this. Now, we will eliminate what? T here. Now, in equation 2, we have to make t the subject of the formula. In equation 2, we have to make t the subject of the formula. So, making t the subject of the formula, u have to come here. So, if plus u comes to the other side of the equation is minus u. So, equals to at. Divide both sides by a. So, which means our t now equals to v minus u over what? Over a. T equals to v minus u over a. So I can rub this. V minus u over a. I'm just trying to explain to us how those equations are being derived. So here is what? Equation 3. So we can say put t equals to v minus u over a in equation 1. So anywhere you see t, you put what? V minus u. Now, this u plus v can be written as what? V plus u, nothing changes. S equals to v plus u over what? Over 2 multiplied by what? Multiplied by t, and t is what? V minus u over a. So that's what we'll do. So numerator multiply numerator and denominator multiply denominator. So v plus u, v minus u. So 2 times a, 2a. Now, this one brings us to what we learned in GS3, difference of two squares. That is, whenever we have an example, whenever we have a square minus b squared, we say it is what? A plus b into a minus b. So that's what we call difference of what? Of two squares. And that's what we are going to do here. So, which means that if we have v plus u into bracket v minus u, we can actually say that S equals to V square minus what? Minus U square over 2A. Then we cross multiply. So V square minus U square equals to 2AS. So then make V the subject of the formula. So V square equals to U square plus 2AS. That is the fourth equation. Then we have all our equation at hand. So that is all the four equations of linear motion. So after this, I know that we can as well play with some numbers. We'll talk about a little example where all these parameters x, u, t, a can actually feature in. Then you think straight that this is the best equation to solve this question. This is the best equation to solve this other question. Are we together? Together we are. So now, in this point now, let's do some worked examples. Let's do some worked examples. Example 1. Example 1. A train accelerated uniformly from rest until it attains a velocity of 50 meters per second in 10 seconds. 50 meters per second in 10 seconds. Calculate 1. Its acceleration. And 2. The distance covered. So we want to calculate its acceleration and the distance covered. So the question goes thus. It said a train accelerated uniformly from rest until it attains a velocity of 50 meters per second in 10 seconds. Now, quickly, there are some simple terms that I'm supposed to explain earlier, but I can still explain it now. Now, when we talk about, we know velocity, we said is the rate of change of displacement with respect to time. We know acceleration, we said is the rate of change of velocity with time. And one thing yet to speak on is what is speed, what's velocity. So what's the difference between them? One is a scalar quantity and the other is a vector quantity, which simply means that one possesses direction, the other does not. So which means displacement is actually what? A direction base, and speed is not a direction base. So that aside, so let's talk about this. Now, whenever a question tells you that something accelerates uniformly from rest, it shows that what? The initial velocity will be what? 0. Once you hear the word from rest, so it shows that the initial velocity will always be what? Be 0. Now, and then when you hear the word a body goes to rest, then you know that the final velocity will be representing what? 0. But when you hear the word from rest, it shows that the initial velocity will be representing 0. So you need to what? To write out the parameters. Write out the parameters. U equals to 0, which means that the final velocity in this case will be 50 meters per second. And the time in this case will be what? 10 seconds. Now, you were told to find acceleration. You were told to find acceleration. So, those are what were given. Now, in this, we have the parameters to be U, V, T, and A. Which equation of motion suits this parameter? Definitely, it is what? Second equation of motion. V equals to U plus AT. Which means that if this is the case, then we say V equals to 50, U equals to 0, A equals to unknown, then T equals to what? 10. Which simply means that 50 equals to 10A. Divide both sides by 10. Divide both sides by 10. Which simply means that acceleration is now what? 5 meters per second square. Are we together? Acceleration of the body, of the train rather, equals to 5 meters per second square. Now, having said that, we are going to calculate the distance covered by the body. The distance covered by the body. So, with the same parameters. Now, I won't advise us, although if we're so sure of ourselves that we got the acceleration correctly, we can proceed to use it to solve what's it called? The distance. But if we're not so sure, we can what? We can use the earlier given parameters with the distance. But then we're so sure that the answer is correct, so we can pick the distance formula, which is the third equation. Using the third equation, distance equals to ut plus half at squared. So distance equals to u is 0 times t is 10 plus 1 over 2 times a. Our a is 5, which is acceleration. Then our t is what? 10 squared. So s equals to, the whole of this is 0 plus 1 over 2 times 5 times 100. 2 here 1, 2 here 50. So s equals to 5 times 50. So the distance equals to what? 250 meters. Distance equals to 250 meters. And that is the final answer for this equation. That's the final answer for this equation and for this question. I hope with this I've actually been able to establish the fact that acceleration question revolving around motion are very simple. Sincerely, they are very simple. And in our subsequent class, I'll be talking about motion velocity time graph. Be talking about velocity time graph, where we'll be explaining how to use a graphical method to solve this same type of question. We can actually use graphical form of method to solve it. So quickly, let's check if we can take one last example. One last example. Or better still, let me explain one aspect of motion that we would love to work with. So that is motion under gravity. So motion under the influence of gravity. Now, when we talk about motion under gravity, there are two things that are involved. So we talk about what? Downward motion, and we talk about what? Upward, and we talk about upward motion. Now, in this case, I will explain the word gravity. Gravity here simply means what? Free fall. For an object to what? To fall freely. For an object to fall freely. And for an object to fall freely, we know that it can be done under the influence of what? Of force. Because there is a gravity on this. If I lift this thing, it will drop, and this is it. So it goes up, which means that it comes down. That is, if I throw a thing up, when it gets to a maximum point, it drops back. So in downward motion, we said it is done with the aid of gravity. Now, acceleration in this point will now be what? Plus G, which is what? Gravity. Acceleration due to gravity. Now, at the initial point, at the maximum height, we don't know what? We don't know the velocity. When the body is up, we don't know the velocity. So we can say that the initial velocity when the body is up is what? 0. When the body is up, the initial velocity is 0. But then, when the object strikes the ground, final velocity is equals to what? Maximum. Which means it can be given or we can calculate it. And definitely you know that the distance in the previous equation of motion, now we are talking about what? We are talking about height. That is, at what height did the marker fall from myself? So now we are now talking about what? Height. Then we all know that what? It's time bound. So those are what we have. Acceleration, now we represent what? Acceleration due to gravity. We have height, we have maximum, and we have final velocity, and we have initial. Now, but in upward motion is actually different. So which means that initial velocity you use to throw the object up will be maximum. It can be calculated. Now, the final velocity at the maximum height will be what? Will be 0, because myself and yourself were not there to measure the velocity there. Now, acceleration will now be minus G. And, excuse me, the main reason why acceleration is minus G is because it's going against gravity. And whenever it gets to a maximum point, the force at which you exert on the object to pull it up, whenever that force expends, it will start coming back down. And that's where, at that point, the final velocity at that point is 0. So we are still talking about height, and you know that is what? It's time bound. So, which means that the 4 equation of motion will be mirrored in this what? In these given parameters. So let's say the first equation of motion is what? X equals to u plus v over 2t. Now, mirroring it in equation of motion, we say h equals to u plus v over 2t. Now, the second equation, v equals to u plus at. Now, if we are to say it, we'll say the equation under what? Gravity. So we say it is u plus or minus gt. Now, the reason why I'm putting plus or minus is this. For downward motion, we know that g will be positive. For upward motion, g will be negative. Are we together? So the third one, s equals to ut plus half 80 square. Now, for this, it will be h equals to ut plus or minus half gt square. I explained the reason why I'm putting plus or minus. For upward motion, it will be positive. For downward motion, it will be what? Negative. For upward motion, rather it will be negative. That's the value of g will be negative. And for downward motion, because it's towards gravity, it will be what? Positive. Pardon. So v square equals to u square plus 2as. So now, in this case, it will be v square equals to u square plus or minus 2gh. So those are the four equations under what? Motion under gravity. So we can play with some numbers. Example, we can play with some numbers. Example, a fruit falls from a tree of falls from a tree of height 10 meters above the ground. 10 meters above the ground. That's the final thing you'll be given. A, calculate a velocity at when the fruit strikes the ground. The fruit hits the ground. B, calculate the time taken. So now, when we said a fruit falls from a tree of height 10 meters above the ground, now it's a falling fruit, then we know that we are talking about what? Downward motion. Let me rub this. We are not talking about upward motion here. So we are going to use this diagram to explain this question. So now, having said that, the question is what? A fruit falls from a tree of height 10 meters above the ground. Now, what do you notice? The only parameters we're given here is what? The height. Which means that every other one can be gotten. Just so you know that acceleration due to gravity is a constant. G is constant. So that's what? 9.81 meter per second square. But some question will actually tell you take G to be 10 meter per second square. So in this question now, we say take G to be 10 meter per second square. So we've what? We've mirrored the question in a way that will make it easier for us. So now, which equation of motion can we actually use? Let's get the parameters. So solution, let's get the parameters. So then we say, since it's downward motion, this is still the diagram. U is what? 0. Just as we said earlier here. So G is positive, which means is plus 10 meter per second square. So now height is given 10 meter. So, and we are told to find velocity at when the object strikes the ground. Now, see the parameter UGHV. So let's check the equation. Where do we have UGHV? It has to be this last equation, that V square equals U square plus or minus 2GH. V square equals to U square plus or minus 2GH. So that is exactly what we are going to use. Now, in this case, we are not going to use minus because it's not an upward motion. But we are simply going to use what? positive g because it's what? A downward motion. So v square equals to u square plus 2gh. So v is unknown, u is 0 square plus 2 times g is 10 and h is what? Is also 10. So v square equals to what? 200. Then we what? We find square root of both sides. So if we find square root of 200, and that will give us what? 14.14 meter per second.